Tonight, while you sleep, millions of tiny immune cells will wake up inside your brain. They will move through forests of neurons, inspect trillions of connections, and decide what deserves to survive until morning. Most of the time, this is a good thing. In fact, it's one of the reasons you're able to think clearly at all. Without these cells, your brain would slowly become overwhelmed by its own activity.
Every conversation, every face, every random thought, every embarrassing moment from 10 years ago. Nothing would ever be cleaned up. Nothing would ever be removed. Your mind would become a crowded city with no garbage collection. Eventually, it would stop functioning. So every night, a cleanup crew gets to work. Silent, invisible, relentless. And tonight, they are working inside your head.
Meet the microglia, the brain's resident immune cells. If your brain were a city, microglia would be its police force, emergency responders, sanitation workers, and intelligence agency combined. They are constantly searching for signs of trouble, viruses, damaged cells, toxic proteins, anything that doesn't belong. Most people never think about them. They never feel them. They never notice them.
But at this very moment, thousands of microglia are crawling through your brain, watching, inspecting, maintaining, protecting. They have been doing this since before you were born, and if they stopped for even a short time, your brain would begin accumulating damage almost immediately. Which sounds reassuring, until you learn what happens next. Because microglia don't just protect your brain, they reshape it every day, every night, every year of your life. Right now, your brain contains trillions of synaptic connections. These connections are the physical infrastructure of thought itself. Every memory you possess, every skill you've learned, every person you've loved, every fear, every dream. Every piece of your identity exists as patterns spread across these connections. And maintaining that network is incredibly expensive. The human brain consumes enormous amounts of energy. Evolution found a solution. Remove what isn't needed. Strengthen what matters. Destroy what becomes useless. The process is called synaptic pruning, and it is one of the most important maintenance systems in biology. Imagine a massive forest. Every experience you have creates a trail through that forest. The more often you use the trail, the wider it becomes, the stronger it becomes, the easier it becomes to travel. But trails that are never used begin disappearing. Nature slowly reclaims them. Your brain works in a surprisingly similar way. Connections that are frequently activated become stronger. Connections that are ignored become weaker. And eventually, some are removed entirely. Microglia help perform this work. They identify weak connections, break them apart, recycle the components, and make room for stronger networks. Without this process, learning itself becomes difficult. Your brain needs forgetting in order to remember. Which sounds like a contradiction, but it isn't. For every useful memory that survives, countless unnecessary connections disappear. And most of the time, that system works beautifully. Most of the time. Because every security system has a failure mode, every defense mechanism can malfunction, and every intelligence system can make mistakes, including the one inside your skull. Imagine a firefighter responding to a small kitchen fire. Now imagine that same firefighter becoming convinced the entire city is burning. The mission hasn't changed. Protect the city, but the response has become dangerous. This is roughly what happens when microglia enter an overactivated state. Instead of calmly maintaining neural networks, they become aggressive, hypervigilant, over-responsive. The brain's defenders begin acting as if danger is everywhere. And that's where the real story begins. Scientists have spent decades studying why this happens. One of the strongest suspects is inflammation. Not the kind you see when you cut your finger, the kind you don't notice. Low-grade inflammation, chronic inflammation, the slow biological stress that can quietly persist for years. When the body enters this state, inflammatory signals begin circulating through the bloodstream. Some eventually reach the brain. Microglia receive the message. Danger. Threat detected. Stay alert. Remain active. And under the right conditions, they do exactly that. The problem is that the threat may no longer exist, but the alarm keeps ringing. Day after day, night after night, year after year.
At first, nothing feels different. You don't wake up one morning missing your childhood. You don't suddenly forget your name. The process is much quieter than that. You forget where you left your keys. A name takes longer to remember. A conversation becomes fuzzy. A memory feels slightly less vivid than it used to. Small things, easy things to ignore. And that's what makes it dangerous.
Because while you experience the symptoms, the underlying battle remains invisible. Deep inside the brain, microglia continue working, pruning, inspecting, removing, responding to signals they believe are protecting you, even when those signals are wrong. And if the process continues long enough, the consequences begin spreading far beyond ordinary forgetfulness.